Welcome, class. Thank you for joining me for the beginning of Chapter 3. Chapter 3 is going to be all about solving systems of equations. And as you probably remember from Algebra 1, there are many ways of solving systems. To begin this chapter, we're going to have a conversation about reviewing systems by graphing. Now, before we even dive into that, I'm going to do a little example of just, if I give you a point, can you test for me if it actually is a solution to a system or not? So if you look at that first example, is 5, 3 a solution to the following system? And as you can see, what you want to do is by plugging in x equals 5 and y equals 3 into each equation, you will see it works for the first but not the second. So what they did, they put that 5 in wherever there was an x in the equation. They put a 3 in wherever there was a y in the equation, and they tested to see what they got. And for the first one, they actually got that -2 that they were looking for. However, in the second one, you end up getting something that does not equal the 17. So what ends up happening is it worked in the first equation. It didn't work in the second equation. So what ended up happening is now you know it's not a solution. It needs to work in both to be a legitimate solution to the system. Now, to give you some real practice doing this, we're going to start from scratch with an example. So I want you to look down at this example 1. Is 4, -1 a solution to the following system? So what I'm going to do is I'm going to put in 4 for every x, and I'm going to put in -1 for every y. So I'm going to begin focusing on that first equation, x minus y. So x, which is 4, then minus y, and y is -1. So 4 minus -1, that ends up giving you 5. So if you look at the first one, it does end up working. You actually got the 5 that you were supposed to. Now, look at the flip side of this, the second equation. So we have 4 times x, so 4 times 4, plus 3 times y, so 3 times -1. And once again, let's check to see if this works. 4 times 4 gives me 16. 3 times -1 gives me -3. 16 minus 3 gives me 13. So in this instance, it actually ends up working in both equations. We got what we needed. So this one, the answer is yes. This point does work because it gave you true statements in both equations. Flipping to the next page. Now, the real meat of what we want to talk about today is solving by graphing. What I've just shown you is how to check your work. But now we need to start from the very beginning of how do we even get that point. So the first method, the method for today, solving by graphing. So you can see step number 1 basically is just graph both lines. Any method that you choose, so graphing by intercepts, graphing using y equals mx plus b, whatever you're most comfortable with. Now, the way that I'm going to show you, the way I believe students are most comfortable with, is y equals mx plus b form. So we're going to jump right down to the second example, and I'm going to begin by graphing these right away. Now, in order to graph them, first I need to get them to the y equals mx plus b form. So what that means, since both of them are in standard form, first thing I'm going to do, I'm going to move the x over. So I'm going to subtract the 2x from both sides to move it to the other side. Now, my y is negative, which basically means there is a -1 sitting there. So to get my y by itself, I'm going to divide everything by -1. And when I divide by -1, essentially all you're doing is flipping the signs of everything in the equations. So for my first equation, I've got it. I have it solved for y now. So I'm ready to graph it. And remember, when you're graphing, you always start down at the y-intercept. So I'm going to start down at that -5, 2, 3, 4, 5, which puts me right down there. And then I'm going to use my slope to find more points. So my slope is 2 over 1. So that means rise of 2 over 1. Rise of 2 over 1. Rise of 2 over 1. Now, it is extremely important when you're solving by graphing. You want to put as many points as possible because you need to be as accurate as possible. Because you need to see the precise point where your lines cross. So what that means is, again, find as many lines or as many points on that line as possible so you can graph accurately. So I've got my first line done. Now I'm going to focus on my second line. X plus y equals -2. So my goal is the same. I need my y by itself. So I'm going to move my x over. I'm going to subtract it to the other side. So I get y equals -x minus 2. All right. So again, we are going to start with our y-intercept. This time our y-intercept is down at -2. And that -x means I have a slope of -1. But again, thinking in slopes, we usually like thinking in fractions. So really it's -1 over 1. So rise of -1, so down 1, run of 1, over 1. Down 1, over 1. Down 1, over 1. And again, collect as many points as possible because you want your lines to be as accurate as possible. So I've graphed both of my lines. Let's see what the next step is. So I'm going to look back up. So now we're on step 2. Identify the coordinates of where they intersect. That gives you the x and y for both equations. All right, so scrolling back, my lines intersect right here at that red dot that I just made. That intersection represents the solution to this system. So if I identify this, that has an x of 1 and a y of -3. What my graph is telling me is that that is my solution to the system. That is a point that is true in both equations. Now, let's go back and look at the third step. Plug your x and y into the original equations to see if it is in fact the solution. So that's basically what we did on the first page, okay, that first screen. It basically is double checking your work, making sure that you've solved it properly. So I'm going to go back and I'm going to check it really quickly in my equations. So my first equation, 2 times x, well x is -1, minus y, so minus a -3. Minusing a negative is essentially adding, so 2 plus 3 being 5. That is what the equation told me that I should get. So it works in the first equation. Now let's try it in the second one. X, which is 1, plus y, which is -3. 1 plus -3, or 1 minus 3, is -2, which is what I was supposed to get. So basically, I just double checked my work and realized that it is truly the answer. So once you find the intersection, plug it back in, check to see it worked in both equations, and that'll show you that what you have actually worked. Now, there are 2 special cases here, if you recall. If the lines don't intersect at all, if you end up graphing 2 parallel lines, that is going to be a no solution situation. If you graph them and they end up on top of each other, your lines overlap, you are going to put infinitely many solutions. Or if you want to shorten that to IMS, I will accept that too. But those are the two special cases that you may come across in the practice work, on the assessment. So let's do one more example before we end these notes to make sure that we're feeling good about this. And again, in order to graph this, what I'm going to end up doing first is solving both equations for y. I want to be able to graph these in y-intercept form. So first thing I'm going to do, I'm going to move my x over. So subtract 2x from both sides. So 4y equals negative 2x minus 8. Divide by 4. And now I'll have the y by itself. So I have my first equation. I'm going to start down at that negative 2, my y-intercept. And I have a slope of negative 1/2. So that means I go down 1 and over 2. Down 1 over 2. That is my rise over run for this. And again, for these ones, mark as many points as possible so you can keep your lines as straight as possible, because you need to be accurate, very accurate with your graphing. My second equation, we have 3x plus y equals 8. So I'm going to subtract my 3x from both sides. So y equals negative 3x plus 8. So next goal, I'm going to plot that. So I start up at 8. 1, 2, 3, 4, 5, 6, 7, 8. Puts me up there. And now I have a slope of negative 3. I'm going to think of that as negative 3 over 1. So down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, and I'm going to keep going with that pattern. Again, take that pattern as far as you can so you can be as accurate as you can. And as you can see, we found the point of intersection. They are crossing at that red dot that I just made. So let's identify what that dot is. Well, its x value is 1, 2, 3, 4, or 4, it looks like. Y value is down at negative 4. So I've identified what I believe to be the answer. So what I'm going to do is I'm going to check my work now. I want to make sure that I have this right. So I'm going to go back to both equations and plug that in. So 2x, so 2 times 4, plus 4 times y, and y is negative 4. So I get 8 minus 16, which gives me negative 8, which is what I was supposed to get. So it works in the first equation. Now, second equation, 3 times x plus y, which is negative 4. So 12 minus 4 gives me positive 8. And once again, that is what I was supposed to get. So that means that that 4, negative 4 really is my solution. So for these, as you can see, my solution is that point. All that work I just wrote out in black, that is checking my work. All right? So that's not your answer. Your answer is that 4, negative 4. You're looking for the point of intersection, the point where they cross at. I just like to go back and double check all my work to make sure that I did it properly. So that is going to be the end of this first note video. Thank you so much for joining me. Make sure you have all of this written down, and then we will check our notes in class and do our practice work.